The signal from 3i Atlas has finally been decoded, and what artificial intelligence discovered hidden in those transmissions is keeping scientists awake at night. For months, Atlas has been broadcasting complex electromagnetic signals that human cryptographers couldn't crack. The patterns were too intricate, the encoding too sophisticated, the structure too alien for traditional decoding methods. Then a team of researchers fed the raw signal data into an advanced AI system specifically designed to find patterns in seemingly random information. What the AI extracted from those signals changed everything. The decoded message isn't a greeting. It's not a peaceful introduction from curious explorers. According to the AI translation, Atlas is transmitting detailed information about Earth, our atmosphere composition, population density, military capabilities, and resource distribution. It's sending an intelligence report back to something, and based on the signal directionality, that something is located in deep space, potentially receiving regular updates about our planet. But that's not the terrifying part. The AI also detected a countdown embedded in the transmissions, a numerical sequence decreasing with each broadcast cycle, currently showing approximately 23 days remaining. A countdown to what the AI couldn't determine. But the implications are chilling. Whatever Atlas came here to do, it's on a schedule, and we're running out of time. The question isn't whether Atlas is communicating anymore. We now know it is. The terrifying question is who it's talking to, and what happens when that countdown reaches zero. Traditional cryptography failed with Atlas's signals because human experts were looking for patterns that made sense to human minds. The AI succeeded because it looked for patterns that simply existed, regardless of whether they seemed logical to us. The research team used a neural network trained on every known communication system: human languages, computer protocols, mathematical frameworks, even animal communication patterns. They fed it the raw electromagnetic data from Atlas without any pre-processing or assumptions about what form the message might take. A data scientist involved in the project explained the breakthrough. We weren't trying to translate the signal into English or any human language. We were trying to identify if organized information existed in the data structure. The AI found layers of encoding we never would have detected manually because they don't follow any communication principles we use. The AI identified 3 distinct layers in Atlas's transmissions. The first layer was relatively simple: basic mathematical constants and physical laws that establish a shared framework for understanding. This is the universal language that any technological civilization would recognize: prime numbers, atomic weights, speed of light values. But the second layer is where things got interesting. The AI detected encoded imagery, visual information represented in ways that don't match how humans typically encode pictures, but still represent spatial data. When the AI reconstructed these images, researchers were shocked to see detailed maps of Earth's surface showing continents, oceans, major geographical features, and, disturbingly, concentrations of electromagnetic emissions that correspond to human population centers. The third layer contained what the AI interpreted as multidimensional data structures, information encoded across multiple variables simultaneously. This is where the atmospheric composition data, resource distribution analyses, and what appears to be technical assessments of human technology levels were found. The AI's pattern recognition revealed something human analysts missed. Atlas's signals aren't constant. They evolve with each transmission, incorporating new information as Atlas observes more of our solar system. Early signals contained basic planetary data. More recent transmissions include detailed information that could only come from close systematic observation. One particularly unsettling finding: the AI detected correlation patterns between Atlas's signal content and specific human activities. When major cities experience high electromagnetic activity, Atlas's next transmission includes updated data about those locations. When military satellites change orbits, subsequent Atlas signals reflect awareness of those movements. It's not just broadcasting a prepared message. Atlas is actively monitoring Earth and reporting its observations in real time. The AI's translation of Atlas's signals reveals it's transmitting what essentially amounts to a comprehensive intelligence assessment of planet Earth, and the level of detail is deeply concerning. The atmospheric analysis section describes Earth's air composition with precision matching our best scientific measurements. 78% nitrogen, 21% oxygen, trace gases, water vapor concentrations, and even pollutant levels in different regions. This isn't approximation. This is data accurate to fractional percentages. An atmospheric physicist reviewing the decoded information was stunned. Atlas is reporting atmospheric composition data that we only recently confirmed ourselves through satellite measurements. They're detecting trace gases at parts per billion concentrations. That requires sensor technology far more sophisticated than anything we've deployed. The resource distribution section is even more troubling. The AI translation suggests Atlas has mapped locations of major mineral deposits, fossil fuel reserves, freshwater sources, and agricultural zones. It's identifying and cataloging Earth's resources in a way that looks disturbingly like a survey conducted before resource extraction. Population density data appears throughout the transmissions. Atlas has identified major cities, calculated human population concentrations, and mapped patterns of electromagnetic emissions that reveal human technological activity. It knows where we live, how many of us there are, and where our major population centers are located. But perhaps most alarming is what the AI categorized as defensive capability assessment. Portions of the decoded signal contain information about Earth's space-based assets, satellites, space stations, tracking networks, and what appears to be analysis of their capabilities and limitations. A military space analyst who reviewed this section described it as troubling. This is the kind of intelligence gathering you conduct before military operations, mapping defenses, identifying capabilities, assessing response times. If this was a human military doing reconnaissance on another nation, we'd call it preparation for conflict. The signals also include comparative data, information about other celestial bodies in our solar system. Mars is extensively documented, including data about its thin atmosphere, surface composition, and notably the locations where Atlas deployed those mysterious objects during its Mars orbit phase. The Moon is analyzed in detail, surface features, lack of atmosphere, and interestingly, the locations of human-made equipment we've left there from Apollo missions and recent landers. Atlas knows what we've placed on the Moon and where it's located. Perhaps the most chilling aspect of the AI's decoding work is the identification of a countdown sequence embedded throughout Atlas's transmissions, and what that countdown might represent keeps researchers awake with dread. The countdown appears as a decreasing numerical value that repeats in multiple sections of each transmission. The AI identified it by recognizing that this particular number sequence decreases by a consistent amount with each broadcast cycle, eventually projected to reach zero. A mathematician analyzing the countdown explained its significance. This isn't a random decreasing sequence. The rate of decrease is precisely calibrated to reach zero at a specific moment in time. Based on current broadcast intervals and the rate of countdown, we're looking at approximately 23 days until it hits zero. Give or take a day for transmission timing uncertainties. What happens at zero is the terrifying unknown. The AI couldn't determine the countdown's purpose because there's no reference data in the signals explicitly stating what event the countdown measures, but context clues suggest several disturbing possibilities. One section of the decoded transmission contains what the AI interpreted as trajectory data for Atlas itself. These calculations show Atlas's projected position at various future time points. When researchers extrapolated these positions to the moment the countdown reaches zero, they found Atlas would be at its closest approach to Earth, approximately 2.8 million miles away. That proximity isn't coincidence. Atlas has been maneuvering deliberately to position itself at that specific distance at that specific time. Whatever the countdown measures, it's synchronized with Atlas reaching optimal position relative to Earth. The AI also detected increased data density in transmissions as the countdown decreases. Early signals, when the countdown was at higher numbers, contained less information per broadcast. Recent signals, as the countdown approaches zero, are packed with more data transmitted at higher power levels with more frequent broadcast cycles. A communications engineer described this pattern as ominous. Increasing transmission intensity as a deadline approaches suggests urgency. Whatever Atlas is reporting back to, it's sending more information more frequently as this countdown progresses. That's behavior consistent with a mission approaching its critical phase. Most disturbing, the AI identified what appears to be verification protocols in the signals, handshake sequences, and acknowledgement patterns that suggest Atlas is receiving responses from whatever it's transmitting to.